Voyager 1 is the farthest human-made object ever created, now drifting more than 14 billion miles from Earth. Launched in 1977, this small spacecraft has spent nearly 5 decades sailing through the silent darkness of space. In 2012, it crossed into interstellar space, leaving behind the heliosphere, a giant bubble formed by the Sun's solar wind. This was a historic milestone, as Voyager 1 became the first spacecraft to escape the Sun's influence and enter the vast space between the stars. What makes this journey even more amazing is that Voyager 1 was built with 1970s technology, far less powerful than even a modern smartphone or calculator. Yet, despite its age, it continues to send valuable data back to Earth. Its original goal was to study Jupiter and Saturn, but the mission went far beyond expectations. With each flyby, Voyager revealed secrets no one had ever seen, and it kept going, pushing into uncharted space. Even more incredible is that it communicates with a 23-watt transmitter, weaker than a typical refrigerator light bulb. Its signals move at the speed of light, yet they still take over 21 hours to reach Earth. That shows just how vast space really is. Voyager 1 also carries the famous Golden Record, a kind of time capsule for the universe. This disk holds sounds, greetings, and images from Earth, including music, natural noises, and even a human heartbeat. The record features greetings in 55 languages, songs from many cultures, and even sounds of animals and thunder. It's a peaceful message to any alien life who might find it, showing the diversity of life on Earth. The mission was made possible by a rare planetary alignment that happens only once every 176 years. This allowed Voyager 1 to use gravity assists to gain speed by flying close to planets like Jupiter and Saturn. Without these gravity boosts, the journey would have taken decades longer. Instead, Voyager 1 reached the outer planets in just 12 years, showing the power of clever planning in space missions. Thanks to that speed, Voyager 1 made groundbreaking discoveries, like the volcanoes on Jupiter's moon Io, and nitrogen geysers on Triton, Neptune's moon. These findings showed that moons can be just as active as planets. Its twin, Voyager 2, is also still flying and is the only spacecraft to visit Uranus and Neptune, where it uncovered strange magnetic fields and icy ring systems. In recent years, Voyager 1 picked up a faint hum in space, caused by vibrations in interstellar gas. Scientists compare it to raindrops falling on a metal roof, only this rain is made of charged particles drifting in deep space. Despite having only 69 kilobytes of memory, less than one digital photo today, Voyager 1 still works. It's powered by a radioisotope thermoelectric generator, which uses the heat from decaying plutonium to create electricity. This power source was only expected to last until 2025, yet it continues to support the spacecraft's mission of discovery. Even after its systems go silent, Voyager 1 will drift through the Milky Way, carrying a legacy of exploration. Along the way, it has shown us amazing sights like lightning storms on Jupiter and the hexagon-shaped storm on Saturn's pole. Each new finding has reshaped planetary science forever. Crossing into interstellar space wasn't a sudden change, it was carefully tracked by watching cosmic rays and plasma levels. Oddly, the direction of the magnetic field didn't shift as expected, suggesting the Sun's reach may be greater than we thought. The spacecraft endures freezing temperatures, cosmic radiation, and the constant risk of failure. Yet, it keeps flying, with every command from Earth taking days to arrive. Each move must be carefully calculated and timed. Its simple, tough design is part of why it still works. Fewer moving parts mean less can break. That's a key lesson for today's space engineers designing future missions. Every signal Voyager 1 sends is like a whisper from the edge of our solar system. These faint messages are picked up by NASA's Deep Space Network, a set of massive antennas tuned to hear signals from across space. These antennas filter out the noise of the universe, helping us hear Voyager's tiny voice from billions of miles away. It's like catching a single drop in an endless rainstorm. The entire Voyager program cost around $865 million at launch, about $4 billion today. For that price, we've gained decades of science and insight into space that no other mission could provide. Today, Voyager 1 is moving at 38,000 miles per hour. Even at that speed, it would take over 73,000 years to reach the closest star. Its path will pass through the Oort cloud, a region filled with icy debris. It will take 300 years to enter the cloud and 30,000 years to leave it entirely. Voyager will drift silently, carrying the golden record, our attempt to speak to the unknown. This record includes images of DNA, families, traffic, and even the brainwaves of a person in love. It's more than just a disk, it's a message from humanity to time and space. It shows who we are, what we value, and how we dream. The Voyager mission reminds us how small we are, yet how far we can reach when we explore together. Subscribe to our channel and thanks for watching.